Hi, my name is Miren Vizcaíno, and I work at the Delft University of Technology at the Department of Geoscience and Remote Sensing. I'm going to talk to you about ice sheets and glaciers. Ice sheets and glaciers form from snowfall that accumulates over land over thousands of years, reaching thicknesses of hundreds to a few thousand meters. The accumulated snow compacts due to its own weight. In this process, pore space is reduced until it turns into ice at depth. Densities range between 200 kilograms per cubic meter for fresh snow at the surface and 910 for ice at depths between a few and 100 meters. The layers with densities between snow and ice are called firn. Refrozen meltwater creates ice layers at the surface or at depth. According to size, land ice is classified into mountain glaciers, ice caps, and ice sheets. Mountain glaciers and ice caps have a total volume equivalent to 0.5 meters of sea level rise. The continental-sized ice sheets of Greenland and Antarctica have 7 and 56 meters, respectively. Ice is a viscous fluid that moves due to gravity. For grounded ice, velocities increase from the bottom layers to the surface. At the lower boundary with the bedrock, ice velocities are null in the absence of liquid water or sediments. In the places with a sliding or high slope, velocities are high. In the ice sheets, surface velocities range from some meters per year in the interior to several hundred at the margins. Glaciers gain mass through snowfall. At the surface, they lose mass due to surface melt and runoff, and sublimation. In the places where land ice reaches the ocean, it melts from ocean heat and produces icebergs. Increased ice flow results in higher discharge to the ocean. Due to its warmer climate, Greenland has surface melt, Antarctica almost none. Almost all glaciers and ice caps have surface melt, except some high-altitude glaciers like Kilimanjaro, which loses mass through sublimation. Surface melt occurs during spring and summer at low elevations. An important fraction of meltwater usually refreezes within the snowpack and does not contribute to runoff. When an ice body is in equilibrium, the gains from accumulation are balanced by the losses from ice discharge, runoff, and sublimation. At the moment, most of glaciers and the two ice sheets are losing mass. The Greenland ice sheet is losing mass due to similar contributions of increased melt and higher velocities. The Antarctic ice sheet is losing mass only due to higher velocities. In an ice sheet, ice flows from the dry, cold interiors to the margins. When it reaches the ocean, it may float or move on contact with the submarine bedrock. In Antarctica, most of marginal ice floats in the form of ice shelves, some of them with an area equal to Germany. In Greenland, most of ice is discharged through glaciers of a few kilometers width that do not have a floating tank. Current higher velocities are caused by increased melt by the ocean. This extra melt makes fast-flowing parts to retreat, reducing the area of contact with glacier walls and supporting bedrock, which reduces the friction. Global warming is expected to increase surface melt and runoff over the Greenland ice sheet, intensifying the current trend. Ice caps and mountain glaciers will shrink dramatically during this century. Observational evidence and modeling studies indicate that increased ice discharge to the ocean will continue into the future. As an example, the fastest glacier in Greenland, Jakobshavn, has been receding in the last few years with high rates of iceberg production. The glaciers terminating in the Amundsen Sea of Antarctica have accelerated as well, and recent studies indicate that the mass loss is unstoppable.